In this video, I will show the first steps, the first manual fits using two temperature model, and then the second part will show the automatic routine. I decided to split it into the two videos because usually you do the first part only once, and then when you already know the shift for this set of measurement, you do not change it because the shift is the same. Sometimes you want to change the shift for different files. Additionally, you want to know approximate parameters for fit, then you will later define in the boundaries. The fit is iterative, you can do one fit, then you like fit, you don't like fit, you change the parameter, you do another fit. But the first step, the manual process, and then the second, third, automatic processes, they differ a little bit. Another thing that I will mention that I did not mention in previous videos, but important thing that the program, for example, here I have all the files, the program saves scan text boxes, the program saves checkboxes each time you do the automatic fit here. So if when I click fit all, it will save all the parameters. So if you want to save your parameters that you include in the model, so for example 80, 35 and the others, you click fit all, and the last parameters that you have, they will be here. Then let's do a quick test. So let's say I don't know the shift, I will put manually shift 0, and then I will go to browse, I will choose prepared the file. Then another thing, I already have my file saved into a separate folder, but for the educational purposes, I have heat capacity here too. So I will copy the heat capacity here, and then separately make sure that when you click browse and then you choose files, the only thing that you do, you put the name of the file and the path to the file in the correct way. So then I don't know how much points I will use, so I will load the entire file. For example, firstly, you can see that it's 40,000 points. For example, I want less, I want less points. Secondly, you see that data is plateau at here, so I don't have to include all, so I can also ignore some points. And here how the process, how it looks like, maybe I can ignore a little bit less, and then but in the scan I will use only this part of 4 points. Then from which fit region I will start, let's say I will start from 200, the 0 is somewhere here, 250, maybe 300, so I don't know which one the 0 is here. The program only gives you the 0 on the first point, so I know the first point is minus 0.59 minus 0.6, and then the last point I know. So for these parameters, I can already click fit open scan, and after some time, usually it does not take much, but sometimes it takes, you see that my two temperature model fit is shifted, and it's shifted a lot. So, but still it chooses the best parameters for the best A and B for given G and tau. So let me shift it. For example, I will shift 01, you have to reopen, and then you have to go to the scans that you want to fit. You see that it's already better. And then if I shift 02, I need to load, I need to go to the scan, I fit, it's decent fit, but you can say, okay, what happens if I change the parameters? So first I will change the tau. Let's say I have bigger tau. For changing tau, actually, you don't have to reopen file. You see what happens. Effect is similar to zero shift. But let's say I choose very low tau like this, but then I also increase the zero shift, which is also important. To change the zero shift, you have to reload the data, and you can see that in this way I still shift to the same direction. Let me change the zero shift in another direction, and maybe even more, to show you what happens. This is very educational situation. Let me fit, for example, here it's clear then here it's the zero shift, maybe tau. In this case, you know that tau is already optimized, but zero shift is not. So you could try to optimize the tau maybe a little bit more, but you will see this kind of crossing that your data goes, your two temperature model fit drops later than data, but then it at some point they cross. It means that the zero shift is not optimized, that your zero shift is should be changed. And then there is also another situation where let me put negative shift and pretty big tau. So I go, I fit. So this is very big tau, probably the fit. Actually, let me put much more zero shift, go to fit the scan, and maybe more. So here the second situation is harder to achieve, but there is another possible situation where you actually, let's see, yeah, I think I will be able to achieve it now. So with some parameters is when it's also different kind of crossing, but here, as you can see, my feed drops earlier than my experimental data, and then they cross. So this kind of crossing of your data means that even though, as you can see, that the initial drop that electrons thermalization defines, it's pretty good fit that you have zero before, you have minimum at the same position, you have good fit. This kind of crossing that the data and the two temperature model fit are not in the same place. You have one starting earlier than other and then crossing, or vice versa. Temperature model starts earlier than cross. This kind of cross may signify that the way you define your time delay and the ways you need to shift your data for fit is not optimal. And one option is to do it manually, as I did. Another option also here is also check zero shifts that use these parameters. For example, with this, it does not use steps. Previous version used steps, but this version does not. And then the same for this. I will go through all the zero shifts from negative to this value positive, and all the taus from these values to these values, and then I will check it. Additionally, before checking zero shifts, I recommend to do pretty good manual fit. For example, in this case, I know it's something around 0.2 shifts, and then something around 0.13 tau. And I go to the last fluence because the last fluence usually is the best signal. And before checking the zero shift, I advise to test the coupling strength G the best way possible, because if G is not optimized, it also can affect the model a little bit. So you see, when the G is too slow, it does not plateaus, and it also you have this kind of crossing. If it's too much, you can see that it plateaus too early, and then it also affects the minimum that you want to have this minimum as good as possible to look for zero shift. So let's put it for 650, and that's the reason why the fit is iterating. So this is my manual fit that I know approximate parameters, but then if I do automatic fit and I see that parameters were off, I can repeat the zero shift, I can repeat all fits. So at this point, my manual fit is already done. I can go and do check zero shift for open scan. Zero shift takes a little bit more time because it can go through all the parameters. That's why there is an option check zero shifts for all files. But to do this, you firstly need to do automatic scan, and most of the time it's redundant. It's much better to do for one scan, and still, for example, here our pulse width is something like 35 femtoseconds, and then based on noise, the algorithm will still cannot give you much more accurate zero position than you can get by eye. For example, here, as you can see, my rough estimation was 0.2, but then you can see that actually I have 0.32 zero shift. So if I add here 32, and then you can see that this parameter is the same as 650, and here I have my tau is a little bit different. So let's try to open with this constant. I open, I go, and I fit, and you will see that indeed my zero shift is much better, so there is not really a crossing, that the data follows very precise. But as you can see here, I actually have some kind of crossing, but that is due to my rough estimate of this parameter that was not optimized during the zero shift search. So at this stage, the most important thing, I know these parameters, and I can keep this fit. And I will show in the next video how to do the automatic fit process.